Hi, I'm here to talk about the potency of acids and bases and what causes the differences between the strengths of acids and bases. So, bases are defined as ion receptors by the Bronsted-Lowry theory, meaning that when a compound is combined with water, it takes one of the hydrogen ions away from the H2O and it creates a base and OH negative, which is an ionic compound technically. How easily a base is able to pick up that ion is part of its strength. However, the strength of a base is also defined as its ability to hold onto that ion, so its stability with the ion. Here's an example. Alright, so here I will be comparing ammonium versus methylamine. So here, in this chemical equation, you can visually see how the H2O combined with ammonia, which is NH3. Here's the structure. The blue is the center, which is nitrogen, and the red are the three H's, the hydrogen. And when those combine, when those react, they form ammonium, which you can see the structure here, and OH negative, which is an ion. And for ammonia, you can see these hydrogens are neutral, but this one's positive, which makes the overall balance, the overall stability of this compound not very stable. However, you can see, here we go. There we go. Alright. With methylamine, you can see here's an alkyl group. This alkyl group makes a really big difference, because when methylamine combines with water, it forms a very stable compound, a very stable base. See, what happens is the alkyl group, it pushes all the electrons here. It pushes them apart, and it causes their charges to be more centered around the nitrogen. And because the nitrogen is very close to this hydrogen, the negative charges from the electrons cancel out, or at least reduce, the positive charge brought by the hydrogen ion, which makes the overall charge and stability greater. I mean, not the charge, but it makes the stability greater. So methylamine is a lot more stable than ammonium as a base. So methylamine is a lot more stable as a base than ammonium. And even though they both receive hydrogen ions, which is stated as the Bronsted-Lowry requirements for a base, it's not as strong a base because it's not as stable as methylamine. So one can conclude that ammonium is a weaker base than methylamine. For acids, it's a similar concept also. However, it's the opposite. The Bronsted-Lowry theory states that acids are hydrogen ion releasers. So they release hydrogen ions into the water, forming H3O and an ion. How easily an acid breaks the bond and releases the hydrogen ion is defined as its strength. The easier it breaks the bond, the stronger the acid is. However, the stability of the created compound needs to be taken into account as well, just like for bases. For example, hydrochloric acid is stronger than ethanol. Ethanol has a difficulty giving up its hydrogen ion because the attraction between oxygen and the hydrogen is very strong, and there isn't enough energy to break that chemical bond. Also, the ethanol without the hydrogen ion isn't stable enough. So, there's a lot of trouble breaking the bond right here. And if that bond can't break, then the acid can't give off this hydrogen ion. And then it can't combine with H2O and form H3O. And so the reaction, it requires a lot of energy. And a lot of energy is not easy to find. So very few of these bonds are broken, meaning that this is a very weak base, because this is a lot more stable, and a lot easier to come by than this, if they were broken. On the other hand, we have a very strong acid, which is hydrochloric acid. Now, hydrochloric acid, you can see it's an ionic compound here. And combined with H2O, it forms H3O and Cl negative, which is an ion. Now, well, Cl negative is an ion and it's not super stable by itself. H3O is very stable. So this bond can't be broken merely by this attraction. The attraction of the negative Cl and the positive H ion, which is now neutralized due to the oxygen's negative charge and negative electrons. So there's a lot more stability going on here than here, and in this case the hydrogen ion is actually given up. Well, in this case it's very difficult. So there are two requirements for both bases and acids. One, for bases, the hydrogen ion must be received. For acids, the ion must be given off. But for both, the end result must be stable in order for it to be considered a very strong base or a very strong acid. So the stability is taken into account as well as how easily it gives off or receives the hydrogen ion, meaning the potency of an acid and base is not quite as simple as some people might have thought. So I hope you're informed, and thank you for watching.